Hello everyone, this is Professor Chan from Math 1245 speaking. Today we're going to be going over section 3.7, which is a concept called variation. Okay, this one's a little bit different than all the other sections we've been doing. So it is kind of a standalone section right here compared to the rest of chapter 3. So let's talk about the following here. So when we're talking about variation, we're talking about a relationship between two variables. Okay. So let's talk about this concept for the letter what's called k. So it says all variation types of relationships has a k, which stands for a constant. Okay. So what does it mean when we were talking about a constant? Remember, a constant essentially is that you have a letter that represents the same number over and over and over again. So example, like pi, right? The letter pi represents its 3.14159. So it's always that number over and over again. Okay? So k is actually a constant number, and then we use that in addition with two other letters, which is y and x. Okay? But y and x are variables, okay? And remember, variables, the numbers can change depending on the equation. Okay? So let's talk about the following here. So when we're doing types of variations, okay, I'm going to just kind of briefly write all these out. So you have what's called direct variation. And the formula for direct is going to be y is equal to k times x. Okay? So what is that saying? We're saying as x increases, so does y increases as well, right? And then if x decreases, then so does y. So that's what means direct. So when we say direct variation, we are saying that, right, x and y are both growing or decreasing at the same in the same direction. Okay. The second type of variation is what's called y is equal to k over x. It's called indirect. It's also, we also use the word inversely as well. So as x increases, y decreases, and if x decreases, y increases. So the idea is indirectly your x and y is going to go in opposite directions based off of growth. Okay. The third one's called joint. So you see the word jointly. It's essentially just directly, but we're using three letters. Okay. So we're just saying when x and z increase, so will y. And if x and z decrease, so will y. Okay? And then the last one we have is what's called compound, which is just a combination of 1 to 3. Okay? So let's talk about the following here. Okay? The following here is essentially, it's not very difficult. So what's going to happen is you just have to figure out if it's direct, indirect, joint, or compound. And then all of them essentially have the same 4-step key procedures. Okay? And if you scroll over, so idea is we write the generic, which means we write one of the equations, we set it up, we find our k, we write the equation, we rewrite the variation of the equation, and then we answer the question. Okay? So let me look at a couple examples. So let's look at, for example, direct. Okay? So the thing that you should realize, for example, if I take a look at number 1, is the following here. I'm going to give myself some room. Because notice it says varies directly, okay? That's a key giveaway, okay? So the word varies directly, okay, means I'm going to do y is equal to k times x, okay? Now, this time, though, they do use different letters, okay? So you do want to write what your letters are and what they represent. So C is cost, and G is number of gallons. So if I'm varying directly, it's going to be C is equal to K times G. Okay? How do I know, right? I'm using the formula up here, right? Directly is C is equal to K times G, right? And the thing is, it looks like, and the situation is that if you notice, if you're reading it, it's kind of in order, right? So C varies directly with G, so Y varies directly with X. Okay, that's the way you want to take a look at that. Okay. So the first thing we always want to do is we want to establish kind of which equation we're using. So it's directly, so I say C equals K times G. Okay? And generally it goes in order too. So the second sentence says, suppose that if I pump 8 gallons of gas, you get $23.20. So I'm going to find K by plugging in these numbers. So cost is $23.20 and G is 8. So I really essentially have $23.20 is equal to 8 times K. So I'll divide both sides by 8. And I have K is 2.9, okay? So remember remember the following here. If K is 2.9, that means K will always be 2.9 because 2.9 is a constant, okay? So what's the difference between K versus C and G, right? K will always be that same number, 2.9. C and G, even though they're letters, they could be represented by any specific number, okay? Right? So C could be $23.20. C could even be $50, depending on whatever G becomes. So C and G can change in many different ways, but K will always be 2.9 based off of our problem. So once I'm done finding my K, I'm going to rewrite this. So I say C is equal to 2.9 times G. And then the last part says, if I pump 5.6 gallons, what will the cost be? So all I do is I plug 5.6 into G, and I just solve for my answer. 2.9 times 5.6. So C is equal to $16.24. Okay, make sure you label what your answer is going to be in terms of what units or what labels. But under that, that's it. Okay. So let's look at another example. It says, suppose the cost of purchasing chocolate-covered almonds varies directly in weight. Okay, so varies directly gives it away once again. So I'm going to do C is equal to K times W. Write what your C represents. So C is cost, or at least kind of market, and W is weight, so we understand. We also want to write what we're measuring. So notice weight is in pounds, and then cost is in terms of dollars. Okay. So I establish my relationship. And then once again, if you just read in order, it just kind of naturally falls in the flow of your structure of your problem. So the next sentence gives us 5 pounds of chocolates results in $28. I just plug this in. Okay, so now I'm going to divide it. So divide both sides by 5. K is equal to 5.6. So that means K will always be 5.6. I'm going to reestablish. So when I say reestablish, right, it's just saying I'm just redoing my variation, but now I know my K, so I just replace my K with that number. And it says, how much will it cost to purchase 3.5 pounds? So I'm going to multiply and plug this in. So cost is $19.60. Okay, so we're going to do another example. Yeah, so let's take a look at, for example, number 2 here. Okay, I kind of want to go over this one because this one's a little bit trickier. So number 2 says the following here. It says intensity of light varies inversely with the square of the distance from the ball. So inversely kind of gives it away. So let's talk about this here. So the first thing I want to do, okay, before I start, is I'm going to measure, I want to write out kind of what I have. So I have I'm going to call it intensity. And I also want to write it in terms of the unit. So this is foot candles. And then D is distance. And this is measured in, let's see, meters. Okay. So the thing I want to be mindful about, is I want to write my letters, what they represent, and how they're measured, okay, so that I don't confuse myself. And this is something going to be pretty evident as we get to some more complicated. It's not difficult, but you just have to be really careful in how you read things. So notice it says, intensity of light varies inversely with the distance of the bulb. So inversely, you'll say I is equal to K over, now we're going to be careful, it says we're going to do D square because it says square of the distance, okay? So square of the distance will be square. If it's cube of the distance, it'll be like D cubed, okay? So now, the structure though is still the same. You're still going to read along and says suppose intensity of a 100-watt light bulb at a distance of 2 meters is 0.075 foot candles. And this is why we label our units so we know what we're talking about. Distance of 2 meters is 4. So I'm going to do 2 square. And then my intensity is going to be 0.075. Be really careful. This 100 light bulb is actually irrelevant. It doesn't represent either of our two letters. So I have K over 4. I'm going to multiply 0.075 by 4. And I have K is equal to 0.3. Okay? So I'm going to rewrite my formula, which is I is equal to 0.3 over D squared. And then the last thing it says, find the intensity of the bulb at a distance of 3 meters. So it's 0.3 over 3 squared, or 0.3 divided by 9. And it's 0.0333. Okay. You can write it as a fraction or you can write it as a decimal. So actually, let's write it as a fraction if I want. Remember, you do math and frac. And this is 1/30th. So I is equal to 1/30th of a foot candle. Okay. Now just make sure, right, on the homework, okay, online, write it as, if they ask you to write it as decimal, obviously follow instruction. If they ask you to write as a fraction, do so for here. Okay. Now, this brings up to a good point I want to talk about for K, okay? So, your K, or your constant, must be exact, okay? So, we're okay, right, because it's 0.3, and it stops, right? But remember, if I have like K is equal to 0.3 repetent, right, 0.33333, so forth, I can't write K as that because if I plug it in, I'm not going to get an exact answer at the end. So what you have to do is, right, if you have a repeating decimal, right, that it does not end, right, that means you have to rewrite it as a fraction, okay? And we will run into that later on. Okay. But if you notice, once again, right, other than reading it carefully, it's the same four-step process. The only thing different from the first two was that I realized it's inversely, which means indirectly as well. Okay. Okay, let's move on to another example here. Let's go to number 3 on page 5 here. Okay. It says the kinetic energy of an object varies jointly with its mass and the square of its velocity. The kinetic energy of a 110 kilogram linebacker running at 9 meters per second is 4455 joules. Determine the kinetic energy of a 140 kilogram linebacker running at 5 meters per second. Okay, so we want to write everything out. We want to label. So it says K is kinetic energy. Okay, and I want to write the units. That is going to be joules. M is mass. And that is in kilograms. And then V is velocity. And that is going to be meters per second. If I do this little backslash, that means per. Okay. So notice I'm going to do the following. Okay. Varies jointly. So jointly, remember, is a relationship between 3 letters. So I have large K varies jointly. So it'll be little k times m times v. Okay. Yeah, just be really careful. Big K represents kinetic energy. Little k represents my constant. So let's take a look at here. So I read the second sentence right here. So big K, oops, sorry, let me go back. So all I do is I replace everything as normal, like what we've been doing before. So 4455 joules is going to be big K. And then the little k stays, and I have the mass of 110 times 9. Okay? So I have 990K, 4455, divide both sides by 990. Okay? So let's do this here. Okay? So I have K is equal to 4.5. And then I once again I do the same 4-step formula right here. Okay? So, right, it's going to look like this. K is equal to 4.5 times m times v. And then I look at the last sentence, and that kind of helps us out, right? So determine the kinetic energy, large K, of a 440 kilogram linebacker. So 4.5 times 140 times 5. That's 3150. So K is equal to 3150 joules. Okay. Okay. So let's do one last one. Let's do a compound one. Okay. But yeah, so once again, if you notice when we do joint, other than the formula itself, right, it's just the same 4-step repeating, okay, over and over again. Just make sure you read carefully, and things should be okay for the following. Okay. Okay, so I'm going to show you number 2. This is on page 6 here. this one is compound. Now, if you look at this problem here, it never says compound. So compound problems will never say compound, okay? And do keep that in mind here, okay? But how do we know something is compound is a lot of times they just combine one of our three, right? So notice it says varies directly and inversely, okay, for the following here. So before I start, I want to once again write my letters. So I have V. This is volume. Volumes in terms of liters. I have T, which is temperature, and that is in terms of Kelvin. And then pressure is going to be, yeah, P is pressure, and it measures in atmospheres, or ATM, okay? And just read, so one thing with compound that can be kind of like frustrating is it's really easy to forget one of your letters. So just make sure you read this very first sentence carefully, right? So I have volume varies with temperature and inversely with pressure, okay? So I have my three letters, okay, or my three variables. So when I start off, this is going to be V is equal to, so notice it says varies directly with temperature, so it's lowercase k and T, and inversely with pressure, so P will actually go on the bottom here. So what we're going to do next, we're going to plug everything in. So a cylinder contains oxygen at a temperature of 300 Kelvin. Oops, my bad. Okay, as you can see, easy to mess up if you're not careful. Okay, so measures a temperature of 300 Kelvin, so the temperature is 300, pressure is 15, volume is at 100. So I'll do the 300 by 15 first. So I have 20K is 100, divide both sides by 20, K is equal to 5. Let me double check that really quickly. Temperature of 300 and a pressure of 15. Yes, okay. And volume is 100. Okay. So, once again, we're going to redo this here. I have V is equal to 300, sorry, not 300. So my K is replaced with 5, so I have 5T all over P. Okay. Now, be really careful right here, right? So this last sentence, right? We've been kind of going autopilot where the letter by itself we saw, but notice this time we're trying to find pressure, okay? So I'm still plugging everything in like normal. It's just that I have to make sure I'm solving for P and not for V, right? So it says the temperature, sorry, the volume occupied by gas becomes a 70 liters, so 70 will go here. Temperature is 315 K, so 315 is going to go here. Okay. So remember, how do I solve this? Just cross multiply this part here. So I have 70P. $15.75, and then divide both sides by 70. Okay. P is equal to 22.5. Make sure your label is going to be ATMs. Okay. So this is what a compound problem looks like. Okay. So compound will never directly state that it's compound. It just be a combination of one of your three. Okay. So if you notice with section 3.7, okay, it's essentially the same four-step procedure. You just have to make sure you're starting off correctly. If you know the math is actually not very difficult compared to the other stuff that we did, you just make sure you have to read carefully. So this is key. Make sure you write your letters, what they represent, okay? That's going to help you guide things along, okay? But other than that, that's it, okay? So we are actually done with chapter 3. Make sure you do study for your midterm, upcoming midterm for chapter 3. If you have questions, once again, let me know. Send me an email or post on the discussion board. But other than that, I'll see you guys later.